All right, let's jump right in. It's a question that pops up all the time, and it sounds so simple. If we know the chemical recipe for oil, why can't we just, make more of it? It seems like a no-brainer, but the answer is going to take us on a wild ride through physics, economics, and some seriously cutting-edge science. And look, it's a fantastic question. This one was asked on Reddit's Explain Like I'm Five, and it gets right to the point. We know what atoms are in there, so can't we just snap them together like Legos? Well, the answers, they touch on everything from the fundamental laws of the universe to some mind-blowing new tech. So let's break it down. So the first big roadblock here, and it's a huge one, has nothing to do with how smart we are or how good our technology is. It's a fundamental problem baked into the rules of physics itself. You could call it the energy trap. Okay, so this all boils down to something called the first law of thermodynamics. It's basically the universe's ultimate rulebook for energy. The simplest way to think about it is this. Any fuel is just a charged battery. You have to plug it in and put energy into it to charge it up. When you use the fuel, you get that energy back out. But here's the kicker. You can never get more energy out than what you put in, ever. In the real world, you actually always lose a bit along the way, usually as waste heat. And that just completely changes how you think about fossil fuels, right? They aren't some magical source of brand new energy. They are, quite literally, a planetary-scale battery that nature has been slowly charging for us over hundreds of millions of years. All that ancient sunlight got captured by plants and plankton, and we're just now tapping into an energy savings account that took eons to fill. Someone on that Reddit thread came up with a brilliant analogy, and it's just perfect. Think about baking a cake. You pump a ton of energy from your oven into the batter to make it. But what if you then tried to burn the finished cake to get heat? There's no way you'd get back all the energy your oven used. It's exactly the same idea. Making fuel from scratch is always a net energy loss. Okay, so even if you could somehow get around the laws of physics, which you can't, by the way, there's another giant wall you'd hit. And this one is a lot more familiar. We're talking about the absolutely jaw-dropping financial cost. Just look at this. This is a real-world comparison that'll blow your mind. On one side, you've got the wholesale price of crude oil, pretty cheap. On the other, that's the estimated cost for the brand new, fully synthetic fuel that Formula One is developing for its 2026 season. The difference is just staggering. And no, that is not a typo. Over $600 a gallon. And hey, this isn't just some crazy number for fancy race cars. Other serious estimates for these e-fuels, which are made by pulling CO2 right out of the air, still put the price tag at over $200 per gallon. So the bottom line is pretty clear. Even though it's possible to make it, it is just astronomically expensive compared to just pumping the stuff that nature already made for us out of the ground. All right, so I know what you're thinking. Laws of physics say no, the economics are insane, this whole thing must be a dead end, right? Well, not so fast. Because of course, that is not where this story ends. So let's recap, right? We know it's a losing game on energy, and we know it costs an absolute fortune. So why in the world is anyone even bothering? What's the point? Well, it turns out the goal isn't just to make a cheaper version of gasoline. The goal is to solve a whole different set of problems. And that brings us to a really cool recent breakthrough. A team of scientists developed a new type of catalyst that can take plain old carbon dioxide, the greenhouse gas we're desperate to get rid of, and use electricity to very efficiently turn it directly into liquid propane. And propane is a super common, easy-to-handle fuel. And when you look at the specs, they are, wow, they're seriously impressive. This is way beyond a high school science project. The process has a 91% efficiency, which is incredibly high for this kind of reaction. It produces the fuel fast enough to actually be useful on a commercial scale, and the catalyst itself is really durable. In fact, the scientists who discovered it said the results were almost too good to be true. Okay, but, having a breakthrough in a lab is one thing. Figuring out how and where it fits into the real world, that's a whole different ballgame. This is where this new tech has to face the gauntlet of practical reality. So let's walk through how this would actually play out from start to finish. Step 1, you've got to grab CO2, either from smokestacks or just straight from the air. Step 2, you need a massive amount of clean electricity, think solar and wind, to power this new catalyst that turns the CO2 into propane. And then step 3, and this part's a huge deal, once you have the liquid propane, you can use all the existing pipes, tanks, and trucks we already have to move it around. But remember that energy trap we talked about? Well, here's where it comes back to bite us.
This chart is pretty sobering. If you take 100 units of electricity, go through the whole process to make synthetic propane, and then burn that propane to make electricity again, you only get about 9 of those original units back. Over 90% of your energy just vanishes, which, let's be honest, is terrible if you're trying to replace a battery.
But that's when you realize maybe we've been looking at this all wrong. The point here isn't efficiency, it's storage. Your phone battery is great for storing power for a few hours. But trying to store enough electricity in giant batteries to power a whole country through a long, dark winter, that's almost impossibly expensive. But storing that same massive amount of energy in a giant tank of liquid fuel, that's actually incredibly cheap and simple. So this table really lays out the whole trade-off, the big picture. On the pros side, these e-fuels pack a ton of energy into a small space. That makes them a potential game changer for things like airplanes and massive container ships that just can't run on batteries. And they could solve that huge seasonal storage problem. But on the con side, they are super inefficient and will only ever make sense if we have so much cheap, clean, renewable energy that we don't know what to do with it all. Okay, so after diving into all of that, from basic physics to wild economics and brand new science, where does that leave us? What's the big takeaway here? So the answer to our original question is yes, we can make our own oil. It's probably not going to be powering your car anytime soon, but it could be a really important specialized tool for solving the hardest pieces of the green energy puzzle, like long-haul flights and storing summer sunshine for the winter. And that leads us to the final, really critical question. Is this incredible technology a vital bridge that helps us build a truly renewable future? Or is it a convenient excuse to just keep the fossil fuel era going a little longer? The science is promising, for sure, but how we decide to use it, well, that's going to make all the difference.